We're going to do 3 problems in this video, and they're going to be where we compare volumes of figures given different ratios of things. So we have cylinder A and we have cylinder B. So here's A, here's B, and we're going to be comparing the volumes. So if you read through the whole thing, you'll get to the very end. What is the ratio of the volumes? So I know we're going to be comparing volumes. We may want to go ahead and write the volume formulas down, and that will help us proceed. Now, ratio of the volumes is a comparison between the two in terms of division, like, oh, A is twice that of B, or A is 1/4 of B, and we'd have to divide to figure that out. So let's jump back in, keep reading. Cylinder A has a height that is 1/4 the height of cylinder B. Okay, cylinder A has a height that is 1/4 the height of cylinder B. So whatever the height of cylinder A is, this is cylinder A, it better be 1/4 of that one. Now, you could pick random numbers. That would be totally fine. And I could do great examples with that, but I want to show you, like, in general, how we could do this with variables. So I'm just going to say, well, A is Y. Let me rephrase that. The height of cylinder A is going to be Y. I would use H, but I've already used H right here, so it's not. And it is 1/4 of this one. Well, 1/4 of this one, if that one's Y, this one had better be 4Y. Okay? We're also going to have to deal with the radius. So let's do that as well. And, oh, that was the first sentence. I missed it. Cylinder A has a radius that is twice that of cylinder B. So basically, the bigger one's going to get the coefficient. So the bigger one is going to be twice the size of the smaller one. I'll use X for this. So the X radius here means that this one's going to have a radius that is twice that, so 2x. So we're going to plug those things in. We're going to figure out what happens, and it's going to look a little sloppy and kind of weird, but you'll see where this is going. So the volume of this one is pi times the radius squared times the height, and that's going to give me, let's see, pi times 2 squared, that's 4. We'll put that in the front. Times pi times x squared y. And here, the volume is going to be pi times the radius squared times the height. And we'll just rearrange this one. We'll put the 4 in the front. 4 pi x squared y. And I hope you notice what I noticed. It's a little obvious already. So this is neat. This is really cool. When I do a ratio, when I create a ratio of A to B, I'm going to do, let's see, A divided by B. We'll do it that way. And that's going to give me, this is really obvious. You don't have to write all this if you already know what's about to happen. I have 4 pi x squared y over 4 pi x squared y. And that's going to give me, well, everything cancels and it gives me 1. So my final answer is the volume of A equals the volume of B. Whoa, okay, what? So if I have twice the radius here, but 4 times the height here, I get the same thing when I compare them through division. Interesting. Okay, well, let's move on to another example. You bought 2 spherical beach balls. The larger one has a diameter that is twice the length of the smaller one. Now, clearly in our picture, they look the same, but I'm going to say that this one is larger, and this one's going to be smaller, even though the pictures do not show that. And I want the ratio of the volumes. So let's go ahead and write 4/3 pi r cubed and 4/3 pi r cubed. And we're going to do some sort of ratio on this one as well. Let's put a squiggly. You know, you're going to need some scrap work somewhere. So you bought 2 spherical beach balls. The larger one has a diameter that is twice the length of the smaller one. So twice the length of the smaller diameter. That is the implied word there. And that means that whatever this diameter is, it is twice that one. And I'd love to talk about diameter. I don't want to talk about diameter. I want to talk about radius. So whatever this radius is, this radius is half of that. Okay? So it goes back to something I said a minute ago. The larger one, the longer one in this case, is going to get the coefficient. That is the whole number. Now, I could make the smaller one be 1/2 x and let that be x, and it would work, but it's just going to be a little more convenient. I've done it the other way in a different video. A little more convenient, though, if I say, well, the smaller one's going to just be x, and the larger one is going to be twice that. So if I have twice the diameter, then I also have twice the radius, right? Let's just be real honest. The larger one has a diameter, a radius, that is twice the length of the smaller one. So since we're comparing diameters, I'm also comparing radii with the same ratio. So the volume is 4/3 pi times 2x cubed. Let's go ahead and keep working on that one. So we have 4/3 pi times 8, that's 2 cubed, and then x cubed, and we have a little bit of room left. Let's clean this up. 4/3 times 8, well, that would be 32/3 pi x cubed. Okay. Well, over here, we're going to have 4/3 pi times x cubed. That's all you can do with it. It's 4/3 pi x cubed. So what is the ratio of the volumes of the beach balls? I'm going to divide. They didn't tell me which direction to make this ratio. They didn't say, what's the ratio of the larger to the smaller? But I'm going to do larger to smaller, larger to smaller. And then I'll just write my final answer as a sentence. So 32/3 pi x cubed over 4/3 pi x cubed. And there's clearly some stuff that's about to cancel. We're going to cancel out the pi, the x cubed, and actually we can cancel out the 1/3, and that's going to leave us with 32/4, which is 8. Wow. The larger beach ball, larger ball, is 8 times, I'm going to rephrase that, has. How about I use neat handwriting? The larger ball has 8 times the volume of the smaller ball. Okay. Now we get to a different problem where we're comparing two cylinders of equal height. First cylinder has a radius that's equal to the diameter of the second, so we're going to do that. So we don't even have a picture here, but we're just going to jump right in. So the volume of this one's going to be pi r squared h. The volume of this one's going to be pi r squared h. And just because I don't have a picture, what I think I will write is that my heights are the same. So the heights are going to be the same. Doesn't matter what I pick for the height. I'm just going to let the height be h. So the height is h. Okay, well that means this one's also h. I could let it be y, I could let it be whatever variable I want it to be. Let's separate these two cylinders. Here's the first cylinder, here's the second. The first cylinder has a radius that is equal to the diameter of the second. Actually, let's say first cylinder, second cylinder. Terrible handwriting. First cylinder has a radius that is equal to the diameter of the second. Okay, let's think about it. If I have a radius that's equal to the diameter of something else. All right, let me think of a good way to articulate this. If the radius of this one, we're going to use x in this case, is x, then the diameter of this one is x, so its radius is 1/2 x. And I know I have a fraction here, and I've avoided that in the other ones, but I'm going to go with it on this one. So let's keep driving. Take your fast car and keep on driving. Do-do-do-do. Do-do-do. So this one didn't really change much. It's just pi x squared h. This one's going to be, all right, let's just go ahead and do it all in one step. 1/2 squared is 1/4. And then pi, and then x squared h. And now we're going to find the ratio of the two. And I'm going to just do first divided by second. They didn't say that, but that's just what I'm going to do. So first divided by second is going to give me pi x squared h over 1/4 pi x squared h. And some stuff cancels, and I left the fraction in here on this one because there's some interesting stuff that's about to happen here. We're going to have 1 divided by 1/4. 1 divided by 1/4 is basically dividing a fraction. So a fraction within a fraction, it's a complex fraction. 1 divided by 1/4 is 1 times 4 over 1, which is 4. So I finished that sentence in an awkward place. It's 1 divided by 1/4. So it's 1 times 4 over 1. So anyway, the first cylinder, the fifth cylinder, there we go, let's spell it correctly, cylinder is, or has, 4 times the volume of the second.